question number 2, put your fingers on the ones that we need to flip. How many division symbols, class? 2 of them. So that means both of these problems you're going to flip because they're right after the division sign. So this will turn into multiplication, and we're going to flip this one. Division sign, we're going to flip this one. So I have 4x squared y over 5 times z to the 4th. Right now I'm just flipping them. Z over 2x and 2z over 1. From here, I'm going to break them up into prime factors. 2 times 2. Class, this one becomes what? I have a y, z, 2, and z. Remember, you can combine the 3 separate fractions all together now because by multiplication, you don't need an LCD. Z to the 4th turns into what? And then 2 times x, and then you have a 1. 1 will always be there. Can I cancel a 2?
Yeah.
I differentiate my 2's and z's by putting a line through them. How many x's? I'm going to cancel 1 for 1. Okay, don't be tempted to do 1 and then 2 here. That would be incorrect. Any y's? Let's circle these as we go along to show that we know that you can't cancel them. How many z's? 1, 2, 3. 1, 2, 3. I'm looking for those that are not crossed off. Again, there's always a 1, so. Class, what's left in the numerator? 2 what? 2xy over 5z. This would be our answer. Okay, look at your denominator there in red. Put your fingers on the 2 variables. Now, students are asking me, does it matter if I put 2x or just x? And the answer is, it doesn't matter. Here's the reason why. Class, if you divide by 2 here, x is not equal to what? 0. So you could have just put x is not equal to 0. If we do 5z to the 4th, class, should we take the radical sign or divide by 5? Remember, you're doing PEMDAS backwards. Normally in PEMDAS, you're simplifying going down, and then when you're solving, you actually go up. So there's no addition and subtraction. You're going to do multiplication and division. So I'm going to have z to the 4th not equal to 0. And then you're going to do the exponents. So I'm going to take to the 4th power 4 identical numbers that multiply to be 0. What is it? That'll just be 4 zeros, right? So the answer is 0. So my 2 restrictions are z is equal to 0 and x is not equal to 0. And then here in this problem and the previous problem, you're just working with monomials, they call them. Notice how we didn't have to do any factoring, no GCFs, no X box.